Cauchy's integral theorem, and you have Cauchy's integral formula also. Okay, there is small change between the two, so that I will tell later on. So Cauchy's integral theorem means if f of z is an analytic function, we will discuss each term. If f of z is an analytic function and its derivative f dash z is continuous at each point within and on a closed curve C, then integral of f of z along the closed curve is 0. That means, suppose any closed curve is given. So this is simply connected region. Already we discussed what is simply connected region. That means here it starts and ends at the same point. Okay, it is a closed region, simply connected region. Then if f of z is an analytic function. Now analytic function means, semester 3 you were having this analytic function, means any function which satisfies the Cauchy-Riemann equations ux equal to vy, uy equal to minus vx, that satisfies the Cauchy-Riemann equations, and its differential means its partial derivatives, this ux, uy, vx, vy all are continuous. Okay, such functions are called as analytic functions. Or in short, analytic functions means there exists its derivative. Okay, analytic function, they will have its derivative, or you can differentiate that analytic function. So any function which satisfies Cauchy-Riemann equations and its partial derivatives are continuous. Such functions are analytic functions. Now here f of z is an analytic function and its derivative f dash z is continuous. Now I hope you remember what do you mean by continuous function. Again I will just tell you, continuous function means, suppose f of z is given, say 1 upon z minus 1. F of z equal to 1 upon z minus 1, then this function is said to be continuous if its value at a particular point. So suppose this is given in an interval 0 to 1. Then this function is continuous within this interval 0, 1. In open interval 0, 1, this function is continuous. Suppose I am taking a value between 0 and 1. Say A is a value or C is a value between 0 and 1. So 0 is here, 1 is here, and C is a value between 0 and 1. Then f of z is continuous at C if f of z exists. If f of c exists, then you can say it is continuous. Now if you take any value between 0 and 1, take any value, say 1 by 2, put that value for this z. So it is 1 upon 1 by 2 minus 1, it means you will get a value. Only thing you need to see here, the denominator should not be 0. If the denominator is 0, then f of z equal to 1 upon 0 form will come and it is not defined. Okay, so denominator should not be 0, then such functions are called as continuous functions. So, or f of c exists, obviously f dash c also must exist. Such functions are called as continuous functions. Okay, so that